Is there a toxicologist in the house?
Hi, council members. I'm Kristy Richardson. I'm the state toxicologist with CDPHE. And just to sort of speak to your point, so I think, one of the things that we try to do when we write reports about our data is we try to look at all of those potential health effects combined. One of the challenges that we have is that not all of these substances cause the same effects. And so when you want to look at a risk assessment of environmental exposures, you try to look at, okay, what can cause neurological effects? And you take all of those substances and add them together and try to look at what those look like. And to date, with the data that we've analyzed, we put out one report related to the camel monitoring that we did in Livingston. And even if we add all of the VOCs up together that we're monitoring, we're not seeing levels that would tell us that there's a hazard. And we do that in sort of a complicated way. We look at each substance and compare it to a health-based guideline value, and you get what we call a hazard quotient. It's just the ratio of a substance to the health-based guideline value. And then you add all of those hazard quotients together to get you a hazard index. And we take a really conservative approach. We just add all of them together, regardless of whether or not they cause the same effect. I think the real challenge here, and you were getting to that, I think, with the what's in the drilling mud, right, is that we don't know if we're measuring anything. And despite the super sophisticated instruments that these chemists use, they're not like the CSI instruments where you just put a vial of anything on it and it tells you it's so-and-so's DNA and they're somebody's brother, or it's a feather from this bird, or it's bromite, right? Like, it's not like that. You have to know what you're looking for in order to be able to analyze for it. And so we have that big challenge there. Just to sort of give you some perspective about that, there's 80,000 chemicals, over 80,000 chemicals that are associated with industrial uses in the United States. There are 3,000 of those that are high volume chemicals where we use tons and tons of them in different industries. In a recent paper that was published for looking at not air emissions from oil and gas operations, but looking at what's in produced water, so the fracking fluid and the water that comes up from underground, they found over 1,100 chemicals in that water. And then when we think about the toxicity information, we have toxicity information to conduct risk assessment on just about 160 of those chemicals. So like 15%. And that's just looking at toxicity for an individual chemical. We can try to add up hazard indices and understand that, but that assumes that all of those chemicals act in an additive manner. That is 1 + 1 = 2. It doesn't help us to understand whether perhaps 1 + 1 = 10 or 100, or 1 + 1 = 0.5. We don't have any really good way to quantify that. For some chemicals, we have some information that allows us to do that, but for all of these VOCs that we're talking about, we don't really have a really good quantitative way to do that right now. So I know that that's a really hard question because everybody wants to know, are we measuring the right things? And I think the question is not only are we measuring the right things, but do we have the toxicity information? And unfortunately, for a lot of these chemicals, we don't.
So can you tell me, what do we have toxicity information for?
What do we have toxicity information for? I mean, I can't stand up here and list every chemical that we have toxicity information for. I'm happy to share that article that I mentioned about produced waters that outlines all of the chemicals that they identified and the ones that we have toxicity information for. The things that we talk about most often that we're concerned about, these BTEX compounds, benzene, toluene, ethyl, benzene, xylenes, ethyl toluenes, I would add in there too. Those things we have decent toxicity information for. The other challenge that we have related to toxicity information is we have information for these, but it's not it's not often that we have it at sort of the frequency and duration that people are being exposed to. Most of that information comes either from occupational exposures, where we had people working in factories with really high levels of these compounds for a long period of time, or it comes from animal studies, where we take laboratory animals and expose them to, high benzene concentrations for 6 hours or maybe an hour, but it's not the 20 seconds or 5 minutes that we hear people saying, like, I smelt it for 5 minutes or 10 minutes in my neighborhood and I got this horrible headache. We don't have that resolution to our toxicity information, and it makes it really challenging for us to understand how that plays in. So when we use that information, the scientific studies that have been published, we try to account for that using what we call uncertainty factors, basically safety factors that say, oh, we don't really know about this, or we know that mice and people are different, and we add an uncertainty factor. We divide by 10 or 3 generally. And so we try to account for that, but I think we are developing information that tells us that maybe we're not accounting for all of the chemicals that people are being exposed to, or we're not accounting for the mixtures of exposures, or we're not accounting for those things that we don't know in the right way.